Simplifying the laws of thermodynamics. First of all, before we start discussing the laws of thermodynamics, we must first know what is thermodynamics. Thermodynamics comes from the Greek word thermes or therme, which means heat, and dynamis or dynamicus, which means power or force. Thermo plus dynamics equals heat and power. From this, we can define thermodynamics as a branch of science that deals with heat and power. In other words, heat and work. From this formula, power equals work divided by time, we can say that power is directly proportional to work. The thermodynamics have four laws. The first law of thermodynamics, or the law of conservation of energy, states that energy cannot be created or destroyed. It is only converted into another form of energy. Because of this law, we can say that the total energy of the universe remains constant. One great example of this is the windmill. We can convert the wind energy into mechanical energy and mechanical energy into electrical energy. In simpler words, the first law of thermodynamics is we cannot create energy, we cannot destroy energy, but we can convert energy into another form. The second law of thermodynamics, or the law of increased entropy, states that the entropy of the entire universe will always increase over time. Why is the entropy of the universe increases over time? Well, this is due to the loss of usable energy every time there is an energy transfer. In other words, every energy transfer, it is not 100% efficient and therefore have losses. And these losses contributes to the increase in the entropy of the entire universe. Entropy is the measure of disorder, randomness, and quality of energy. The second law of thermodynamics also states that heat transfer is from hot body to cold body, only unless an outside force will interact. Heat transfer, hot to cold, high temperature to low temperature. To understand this, let's take a closer look at this ice. What happens to this ice is a perfect simple example of entropy. Observe closely. The molecules in the solid state is low in disorder. It means that less heat is present, and the kinetic energy of the molecules is less. As the ice starts to melt and turns into liquid state, it means that more heat is present, and kinetic energy of the molecules starts to increase. As the kinetic energy of the molecules increases, the higher is the disorder or the entropy. And this applies when the liquid evaporates. It has the most kinetic energy and the level of its entropy is at its peak. In this, we can conclude that gases have the highest entropy and the kinetic energy is directly proportional to entropy or disorder. When we say directly proportional, it means that when the kinetic energy increases, the entropy also increases. Temperature is directly proportional to kinetic energy and entropy. Moving on to the third law of thermodynamics, it states that the entropy of a system approaches constant value as the temperature approaches absolute zero. Why is this? This is because at absolute zero temperature, all particles will stop moving, and all kinetic energy that is present in the particles will also drop to zero. Therefore, if there is no kinetic energy present, all disorder disappears, and this means that the entropy of the system is zero. In this realization, we can conclude in simpler means that the third law of thermodynamics is entropy approaches zero as the temperature approaches absolute zero. Just always remember that temperature is directly proportional to kinetic energy, and kinetic energy is directly proportional to entropy. And take note that the absolute zero temperature is 0 Kelvin, or negative 273 degrees Celsius. Let's observe this boiling water. Does it have high entropy? Yes. Why? Because it has high temperature, and the higher the temperature, the higher the kinetic energy of the boiling water. If the particles have more kinetic energy, it will move faster and therefore causes randomness or disorder. And this randomness or disorder is what we call entropy. The ice has less entropy and the boiling water has more entropy. Lastly, the fourth law of thermodynamics, or most commonly known as the zeroth law of thermodynamics, and it states that if two systems are each in thermal equilibrium with a third system, then the two original systems are also in thermal equilibrium to each other. A simple and great example of this is when you get two glasses of water. One glass is hot, about 76 degrees Celsius, and the other is cold, about 16 degrees Celsius. And you both place them in a table at a room temperature of 30 degrees Celsius. You will notice that after a few minutes, the temperature of the two glasses will be equal to the temperature of the room. And if they are both in thermal equilibrium to the temperature of the room, then also they are both in thermal equilibrium to each other. Let's say after 36 minutes, the two glasses reaches 30 degrees Celsius. Note that thermal equilibrium happens when there is no transfer of heat because the temperature of the three systems are the same. In summary, the laws of thermodynamics are: first law of thermodynamics is all about conservation of energy. The second law of thermodynamics is all about entropy. The third law of thermodynamics is all about entropy is zero if the temperature is absolute zero. And lastly, zeroth law of thermodynamics is all about thermal equilibrium. That's all for now, guys, and this video ends here. Like, share, and subscribe. Hanggang sa muli at sabay-sabay nating sabihin, tara, aral!